Good day, everyone. For this particular video, we'll now be discussing about lubrication and lubricants. So to start with, let's review what is tribology. So tribology is a science and engineering of interacting surfaces in relative motion. This is known as tribology. In short, this is actually the science and engineering of friction. It entails a study of application of friction, lubrication, and wear principles. Tribology is highly interdisciplinary, meaning it is composed of different sciences, drawing from physics, chemistry, material science, mathematics, biology, and engineering. Tribologists are individuals who work in the field of tribology. Now, let's talk about lubrication. Lubrication is the control of friction and wear by the introduction of a friction-reducing film between moving surfaces in contact. So as you can see here from this particular image, we have two surfaces that are in relative motion with one another, and there is this yellow substance we call as our friction reducing film, or commonly called as our lubricants. The lubricant used can be a fluid, solid, or liquid or gas, solid or plastic substance. So this is how we illustrate our lubrication. So you have here the normal force on body 1, and we have a body 2 that will receive the particular impact, and we apply here lubrication to smoothen the process and also to avoid damage in our system. So from this diagram, we can see the importance of the use of lubrication. So in the first diagram, load normal force, and we have the motion or movement towards the right, and our frictional force is towards the left. So therefore, in this particular system, there is actually friction. But upon application of our intermediate material we call as lubricant, friction has been eliminated. But take note that friction cannot be totally eliminated in our system but only reduced. So in this particular image, in the second diagram, we can see that there is no frictional force here. And that is the main goal why we do lubrication. So these are the different purpose of lubrication: to keep moving parts apart by forming thin layer between the surfaces. Number two, to reduce friction. As we all know, lubricant to surface friction is lesser than surface to surface friction. Number three, to protect against wear or damage in our system. Lubricant prevent wear by keeping moving parts apart. Number four, to transfer heat. So therefore, our lubricants can also be used as coolant in our system. Liquid lubricants are effective in heat circulation due to high specific capacity. So meaning as we pass through the machineries which are actually overheating during the process, we use lubricant to cool it down. Number five, prevent corrosion. A surface of metal do not come in contact with air. So we can actually prevent corrosion and prolong the life of our machineries. To seal the gaps, lubricants seal the space between moving parts through capillary force, especially through the use of a penetrating lubricant, and to carry away contaminants and debris. So as you've noticed, when you change your oil, you can actually see lube oil, which are dark in color, contaminated with solids, because it could actually act also as a detergent or a cleaning substance in our machinery system. So again, the purpose of lubrication are the following: to keep moving parts apart, to reduce friction, to protect against wear, to transfer heat, to prevent corrosion, to seal the gaps, and to carry away contaminants and debris. So these are the different types of lubrication. The first type is the full film lubrication. This can be broken down into two forms, the hydrodynamic and the elastohydrodynamic. But let's examine first the image in this particular slide. We can see here that two surfaces are actually not totally in contact with one another. As you can see here, there are small gaps in between surfaces. Thus, this is called a full film lubrication. The first type of full film lubrication is the hydrodynamic lubrication, which occurs when two surfaces are in sliding motion. Take note, to talk about hydrodynamic, it must be a sliding motion relative to each other and are fully separated by a film of fluid. Full film. Hydrodynamic. Sliding motion. The next one is our elasto-hydrodynamic lubrication. It's similar but occurs when the surfaces are in rolling motion relative to each other. Take note here, for hydrodynamic, it should be sliding, but for elasto-hydrodynamic, it must be in rolling motion. The film layer in elasto-hydrodynamic conditions is much thinner than that of the hydrodynamic lubrication, and the pressure in the film is greater. Thus, because of this particular pressure, there will be deformation in our system. It is called elastohydrodynamic because the film elastically deforms, as what I mentioned, the rolling surface to lubricate it, based on this particular diagram on the next slide. So as we continue the motion for the rolling element, and as we apply lubrication, there will be a deformity in this particular process, which actually aids to the lubrication process. So this deformation is actually an aid to the rolling element in order for it to be lubricated. Now, let's talk about asperities. So even in the most polished and smooth surfaces, irregularities are present. This is based on the macroscopic level, what we can see in the naked eye, or smooth surface. They stick out of the surface, forming peaks and valleys at the microscopic level. But when we examine it under the microscope, we can actually see the high points and the low points of this particular surface. These peaks are what you call as your asperities. In order for full film conditions to be met, the lubricating film must be thicker than that of the length of the asperities. This type of lubrication protects surfaces the most effectively and is the most desired. So actually, the most desired based on this particular statement or text would be our full film lubrication. But there are also other forms of lubrication, such as the boundary lubrication. Boundary lubrication is found where there are frequent starts and stops, and where shock loading conditions are present. Some oils have extreme pressure or ET or anti-wear additives to help protect surfaces in the event that full films cannot be achieved due to speed, load, or other factors. So as a substitute to the full film or the full fluid film lubrication, we have the boundary lubrication. So as you can see here in our boundary lubrication, our asperities are actually usually and frequently are in contact with one another. So based on this image, as you could recall, for the full fluid film or the full film lubrication, there is actually a gap between two surfaces that are relatively in motion. But for the boundary lubrication, these asperities now are in contact with one another. Boundary lubrication, these additives cling to metal surfaces and form a sacrificial layer that protects the metal from wear. Boundary lubrication occurs when the two surfaces are contacting in such a way that only the EP, or extreme pressure, or the AW, the anti-wear layer, is all that is protecting them. This is not ideal as it causes high friction, heat, and other undesirable effects. So this will be the effect of our boundary lubrication. Mixed lubrication. Mixed lubrication is a cross between boundary and hydrodynamic lubrication. While the bulk of the surfaces are separated by a lubricating layer, the asperities still make contact with each other. So to differentiate mixed lubrication from the two, we have here a particular image showing how our asperities are in contact with one another. So for the full fluid film or fluid film lubrication, there is no contact between asperities. For our boundary lubrication, most of the time our asperities are in contact with one another. But for mixed lubrication, it's actually a combination of the two. So this is where the additives again come into play in our mixed lubrication. Now, let's talk about friction and wear principle. Friction, the resistance to relative motion between two bodies of contact, is known as friction. So always remember that when your motion is going to the right, your friction is always the opposite direction, which means the frictional force is going to the left. The force of friction is directly proportional to the applied load and is independent of the area of the surfaces in contact, meaning once your force or applied load is higher, your friction is also higher. And once it is lower, your friction tends to become lower, meaning they are directly proportional with one another. The electromagnetic attraction between the surfaces, or I mean the charged particles on the two surfaces of contact, is thought to be the cause of this particular friction. So remember again, as we increase our load or the force applied to the particular surface, the friction is higher. But once we decrease the force or the load we apply to the surface, the friction tends to become lower. Now, let's understand Amonton's law. The Amonton's law states that the frictional force and applied load have a relationship of F equals mL, where m is the coefficient of friction, which depends on the materials in contact. So let's first understand this statement depends on the materials in contact. That means different materials have different coefficient of friction. The coefficient of friction for wood is different from the coefficient of friction on a metal surface, on a tile, or on a cemented road. Depending on whether the objects in contact are stationary or moving, the coefficient of friction can change. So as you can see here, as we increase the load from 0 to 250 approximately, we also increase our frictional force. That is based on Amonton's law, meaning we have a direct relationship between your load and your frictional force. Now, let's go to the types of friction. Friction can come in a variety of forms, including static, rolling, kinetic, sliding, and fluid friction. The friction that exists between two objects when they are not moving relative to one another, like a block of wood left on a table, is known as static friction. Here, the forces are in equilibrium, meaning there is no external force or net force that could actually make this body in motion. Therefore, the word static friction. Rolling friction is a term used to describe the frictional force that develops when an object rolls against another surface, such as when a car's wheels rolls up against a rope, rolling friction. And the last would be the kinetic friction, is a kind of friction that develops when two objects are in contact, move in a relation to one another, and rub against one another, like when a child slides down a slide. So to illustrate this particular text, we have this diagram. So if there's no motion, but there are forces acting on a particular body, but it's in equilibrium or at rest, it's known as static friction. Once your body is now sliding back and forth, depending on the force applied and the motion of the body, there is a sliding friction, which is under the kinetic friction that we mentioned earlier. And last, we have the rolling motion here, where you can see actually a cylindrical object rolling on the floor. So your friction is what you call as your rolling friction. That's it for our introductory course on tribology, particular on our discussion on lubrication and lubricants. See you in our next video. Thank you so much.